Every year, nearly 70 billion Lego bricks roll off the assembly lines. Each engineered so precisely, it could snap perfectly onto any Lego piece made since 1958. But before you open the box, there's a hidden world of color labs, molten plastic, and molds built for micron-level accuracy. Tolerances so tight that a single human hair could ruin thousands. How millions of Lego bricks are made inside a mass production facility isn't just about toys. It's a journey into one of the most exacting manufacturing feats in the world. What does it really take to turn ordinary plastic into the most reliable building block of imagination? The answer begins at the microscopic level, and it changes everything you thought you knew about Lego. Step 1. Everything begins with the raw material. Every Lego brick starts life as tiny, translucent pellets of ABS, acrylonitrile butadiene styrene. This plastic isn't chosen by accident. It's prized for its strength, its ability to hold color, and, most importantly, its knack for creating that signature Lego grip. Shipments of ABS granulate arrive at the factory in huge quantities, filling silos that feed the entire production line. These granules might look plain, but they're the foundation of every brick ever made. Before a single brick takes shape, something almost magical happens. Color is added. Inside the factory, deep within a guarded area known as the color lab, scientists blend master batches of pigment with the raw ABS. The palette is legendary. Over 50 official Lego colors, from brick yellow to earth blue, each with its own secret recipe. The formulas are so closely protected that only a handful of experts know every ingredient. Getting the color right isn't just about looks. The pigments must survive intense heat and sunlight, resist fading, and never bleed into other shades, even after decades. If the chemistry is off by a fraction, an entire batch can be ruined. This is why the lab tests every blend for stability, brightness, and safety. No shortcuts allowed. Once the ABS is dyed to perfection, the pellets aren't quite ready for molding. There's a hidden threat: moisture. Even a trace of humidity trapped inside the plastic can cause bubbles, weak spots, or color streaks during molding. To prevent this, the colored granules are sent through powerful pre-drying ovens. Here, they're gently heated to drive off every last drop of water. Only when perfectly dry are the pellets cleared for the next phase. The result is a supply of flawless, vividly colored, and bone-dry ABS pellets, each one a tiny promise of future precision. These granules are now ready to be transformed, setting the stage for the high-pressure world of injection molding that will turn raw material into the building blocks of imagination. Step 2. Transformation begins in the heart of the factory. The colored and dried ABS pellets travel through a maze of pipes, arriving at the injection molding machines, towering, automated giants running day and night. Inside each machine, the pellets are heated to roughly 230 degrees Celsius, or 446 degrees Fahrenheit. At this temperature, the plastic turns into a thick, molten stream, ready to be shaped with absolute precision. The real marvel starts when this liquid plastic is forced into hardened steel molds at pressures reaching 29,000 psi, almost 1,000 times the air in a car tire. Each mold is a feat of engineering, designed for a single brick shape, built to last millions of cycles, and costing anywhere from $50,000 to $200,000. Dozens of cavities line each mold, forming multiple bricks in a single shot. The molds clamp shut, and the machine injects the molten plastic in less than half a second. Then, the plastic cools and solidifies, still under immense pressure, for a few crucial seconds. This brief pause is where perfection is forged. If the timing or temperature is even slightly off, the brick can warp, shrink, or lose its legendary grip. When cooling is complete, the mold opens and a row of flawless bricks is ejected. This choreography repeats every 8 to 10 seconds, with each machine producing up to 36,000 bricks per hour. The pace is relentless, but nothing is left to chance. Sensors monitor every detail, temperature, pressure, cycle time, feeding data to engineers who adjust settings in real time. Any extra plastic, like the runners or sprues, is immediately ground down and recycled, rejoining the process without waste. The molds themselves demand constant care. Toolmakers inspect, clean, and fine-tune them on strict schedules, because even a minor scratch or misalignment could ruin thousands of bricks. Security is tight. Mold designs are guarded secrets, stored in restricted vaults, and only a handful of specialists have access. In this world, precision isn't just a goal, it's the law. The result? Each brick emerges from its mold, ready to meet standards measured in microns, setting the stage for the next round of scrutiny. Freshly ejected from the steel molds, each Lego brick is still warm, its final shape locked in by a cooling process measured in seconds, not milliseconds. This rapid solidification is the first barrier against warping or shrinkage, ensuring that every stud and socket holds its form with unwavering accuracy. But the journey toward perfection is only beginning. As these newborn bricks travel down the line, they enter a realm ruled by machines that never blink. Robotic scanners, equipped with high-resolution cameras and sensors, inspect each piece at lightning speed. In less than a second, these sentinels search for flaws invisible to the human eye. A faint surface blemish, a color that's a shade off, a microscopic deviation in size. The standard is absolute. If a brick strays more than 10 microns from its ideal dimensions, it's instantly rejected. For reference, that's about 1/7 the width of a human hair. Mechanical rigs then test the legendary clutch power, the force needed to snap bricks together and pull them apart. Too tight, and building is a struggle. Too loose, and structures collapse. Only bricks that pass this test move forward. Those that fail are whisked away, ground down, and recycled, never making it into a box. This relentless pursuit of zero defects means that out of every million bricks, only a handful are ever discarded. The result is a level of consistency unmatched in the toy world. A system where every brick, no matter when or where it's made, is ready to become part of something bigger. In this world, precision isn't luck. It's engineered, tested, and guarded by machines that never sleep. Inside the warehouse, a silent ballet of machines takes over. Robotic arms and shuttles glide along towering racks, moving trays of freshly made bricks up to 36 meters high. Each robot knows exactly where to find every one of the 14,000 unique Lego elements, whether it's a classic red 2x4 or a rare curved window. The scale is almost unimaginable. These storage halls can hold enough bricks to fill entire airplane hangars, all sorted by type and color, ready for the next step. When it's time to build a set, the choreography shifts gears. Automated sorting machines count out the exact number of each brick needed. Even the tiniest 1x1 studs are tracked and tallied by sensors more precise than the human eye. Instructions are paired with the right bricks. Boxes are folded and filled at lightning speed, and every package passes a final weight check. If a single piece is missing or out of place, the box is pulled for inspection. No exceptions. Sealed and labeled, the boxes stream onto conveyors, destined for Lego's network of 5 giant factories and distribution centers across Denmark, the Czech Republic, Mexico, China, and Vietnam. From there, sets travel to over 140 countries, reaching store shelves and doorsteps worldwide. Every year, more than 60 billion bricks make this journey, each one engineered to fit with any other, no matter where or when it was made. The proof comes in a simple click, a brand new brick snapping perfectly onto one from 1958, a promise kept across generations and continents. Every year, Lego produces over 60 billion bricks, each manufactured to a tolerance of just 10 microns, 1/7 the width of a human hair. This documentary has shown how ABS plastic pellets become bricks through tightly controlled molding, robotic inspection, and automated storage, all engineered for one purpose: absolute consistency. Every brick, no matter where it's made, must fit with any Lego piece from 1958 to today. Yet, the exact details of Lego's proprietary color formulations and the full scope of its quality control algorithms remain closely held company secrets. More than 400 billion Lego elements now exist worldwide, enough for about 50 per person on Earth. Behind the familiar click of every Lego connection is a world defined by precision, automation, and global reach. The result is a toy system where generations are linked by engineering, proving that even the smallest details can have a massive impact. Viewers are invited to share their own Lego memories, connecting past and present through the timelessness of the brick.